Hello dear students, welcome you all. In this lecture, I am going to discuss a very important topic. In fact, I am starting a new unit in nuclear and particle physics, and the unit is particle physics, and the chapter is elementary particles, right? It is a very interesting unit. In this unit, we are going to discuss the classification of elementary particles, their different properties, and then after we will go to the chapter of cosmic rays, right? So in today's lecture, I am going to discuss about the classification of elementary particle and from where this idea of elementary particle came. Uh, First of all, I want to show you this is GABA, अमरूद है ये, right? Now, what will happen if I cut it down? Suppose I cut it down in the middle, right? Now, इसके ये you can see now it has two pieces, right? Suppose like this is one piece, I put it there. Again, इसको मैंने बीच से काट दिया. Now it is what I am doing. I am making it small and small, right? Now 2 to 4. Now let one more, right? और छोटा कर दिया मैंने. अगर मैं ये छोटे से छोटा करता जाता हूं और छोटा कर दिया, what will happen? Ultimately, if I am able to cut it down into very small pieces, smallest pieces, then ultimately I will reach at the molecular level. Actually, I want to know that ये जो अमरूद था, ये किस चीज से बना हुआ है, right? What is the matter in this object? What is the matter in this fruit, right? I want to know the answer of that question. What is the building block of this? And not only this GABA, all these things that you look at around you, whether it is writing pen or whether it is this knife, all the things are made up of some building blocks that we call elementary particles in high energy physics or nuclear physics, right? And this question was always in the mind of mankind right from the beginning. If you look back into the history, then you know very well, I have already discussed in the class that there is a mention that the first thought and first theory that we look into the history, that was the beliefs of Greek people. And in Greek people even there was a Greek philosopher named as Democritus. And around 2500 years ago, I mean 5th century BC, before Christ, that person proposed that the entire matter in the universe is made up of small particles, and he named those particles in Greek atomos. तो जो आज का हम वर्ड देखते हैं एटम, वो उसी वर्ड एटमोस से आया हुआ है. दैट वाज कॉइन्ड बाय द ग्रीक फिलोसोफर डेमोक्रिटस. I also told you that B people at that time was not behind the Greek philosophers. We do have our own philosopher at that time. We call them as sages, जिनको हम ऋषि बोलते थे या मुनि बोलते थे. तो we have a great sage named आचार्य कणदा. मैंने बताया था आपको पहले भी. And he also have gave the same kind of explanation. And उन्होंने बताया कि ये जितना का जितना मैटर हम देखते हैं यूनिवर्स में, इट इज मेड अप ऑफ स्मॉल पार्टिकल्स, एंड ही नेम्ड देम एज अणु. जो हमारा हिंदी का शब्द था, दैट वाज आई एम डाउटफुल क्या ये संस्कृत का शब्द था, ये हिंदी का, बट वो हमारा ही इंडियन वर्ड था जिसको हमने बोला अणु. तो अकॉर्डिंग टू our own philosophers, right, great says the matter is made up of small particle, that is anu. And according to Greek people, the matter is made up of smallest particle, that is known as atomos, right? But दोनों में ही एक चीज कॉमन थी, और दोनों ही आई थिंक कोई ज्यादा मतलब डिफरेंस नहीं था. It is believed that Greek people have coined this theory earlier, but in some references you can see that the Acharya Karnad was the first person who has coined this. So we don't want to, should not go into all that debate. But the thing was कि दोनों ही जो बातें थी वो एक जैसी थी. एक बात बोल रही थी कि मैटर बना है अणु से, और एक बात बोल रही थी कि मैटर बना है एटोमॉस से. पर जो दोनों एक चीज कॉमन थी वो क्या थी? दोनों ही ये बात बोल रहे थे कि दिस इज द फंडामेंटल पार्टिकल ऑफ द यूनिवर्स. फंडामेंटल मींस जिसको आगे नहीं तोड़ा जा सकता है. दिस इज वेरी इंपॉर्टेंट. आचार्य कणद ने भी यही बोला, और ग्रीक फिलोसफर्स ने भी यही बात बोली कि ये जो एटमॉस है इसको आगे डिविजिबल नहीं किया जा सकता है, इट इज द अल्टीमेट पार्टिकल, और इसी से सारा का सारा जो आप अपने अराउंड ब्रह्मांड देखते हैं, मैटर देखते हैं, एनर्जी देखते हैं, ऑल दीज थिंग्स आर मेड अप ऑफ इट, राइट? But as the time progresses, in the beginning of 90th century, right, when modern science emerges, then the things got changed. You know very well, we have different theories starting from the Dalton atomic theory, J.J. Thomson atomic model, then Rutherford model of atom, then Bohr's atomic model, and all these things, right? So what happened with the progress of time, right? As the mankind evolved, right? जैसे से आदमी को ज्यादा चीजें सोचने को मिली, ज्यादा उसके पास इंफॉर्मेशन आई, ज्यादा उसके पास अच्छे इंस्ट्रूमेंट्स आए, देन इट वाज फाउंड दैट एटमॉस और अणु वाज नॉट द फंडामेंटल पार्टिकल. जब एटमॉस को अंदर देखा गया तो इट इज फाउंड कि दैट उसके अंदर कुछ पार्टिकल्स हैं, और सबसे पहला जो पार्टिकल था दैट वाज डिस्कवर्ड, दैट वाज इलेक्ट्रॉन. इट वाज डिस्कवर्ड इन 1897 by J.J. Thomson, right? उसके बाद जब it was proposed that the atom also contains some kind of positive particles, and then proton was discovered in 1919. Then we have new particles, neutron in 1932, James Chadwick. Then we have positron, and then this list go on increasing. There was no stop in that list. We have a lot of particle coming out of that small atom, right? So then the question was again there, that what was the building block of this universe, right? So if we look at today, then we have more than 200 subatomic particles. We call them as elementary particles. Students, you have to remember the difference between the elementary particles and the fundamental particles. Fundamental particle, I will come to them in this lecture also. Fundamental particles are those particles which cannot be further divided into any other substructure, right? But elementary particle can have substructure, right? Elementary particles are subatomic particles, right? And this list is a very big, large. So in this lecture, I am going to do the classification of these elementary particles, because this is the first thing we should know, that what are the different families of the groups of these elementary particles, what are the properties of these elementary particles. So this lecture deals entirely with the classification of elementary particle, because before going further into this chapter, we should have the knowledge of all these things, right? So now I am coming to the you can see here, this is the classification of elementary particles. So as I told you that at present we have more than 200 elementary particles or subatomic particle present in the nature, right? And all the matter that we see around us, they are present in all that matter, right? So we can classify these elementary particles in three groups. You can see here, right? The group one is a group of light particles. Light means those particles which have very small mass, right? Then we have intermediate particles, and then we have heavy particles. Three groups are there. This is one way of classification of elementary particles: light, intermediate, and heavy. Now light particles, we call them as leptons. You can see here, leptons. Leptons means light particles. And what are the different particles present in this group? Electron, one, then muon, negative, tau, negative. Three particle, E, mu, tau. Once again I am repeating, electron, muon, and then tau particle, right? They also have their antiparticles, but I am not writing them here. For example, electron has antiparticle positron, muon will have a mu positive, tau will have tau positive, but I am not writing them here. Then we have three neutrino associated with these three particles: electron neutrino, right, mu neutrino, and tau neutrino. They also have antiparticles. Antiparticle means bar will be there on this, right? So we can say if we ignore the antiparticles, we have 6 leptons, right? 6 leptons in this family, right? And If I come to intermediate particles, you can see here, intermediate means those have an intermediate mass. I mean, they are not so much light and they are not so much heavy. Intermediate particles contain mesons. You can see here. Now mesons can further divided into three groups. First one is a eta meson, and it is a single particle, eta naught. Eta naught, and it has antiparticle, that means bar will be there, but we are not considering the antiparticle in the family. So eta naught, eta meson. Then we have K mesons. Now K meson family contain only two particles, K positive and K naught, and they have their antiparticle K negative and K naught bar, right? This is K meson, and these are pi mesons. Pi meson family has three members, pi positive, pi naught, and pi negative. So we have to remember that this family contains three particles and they have their antiparticles, right? This is about the mesons, right? Now I am coming to the heavy particles. Heavy particles are known as baryons, right? And baryons are further divided into sorry, two groups. One is nucleons and the second is hyperons. Right? You can see here. Now nucleons means those particles which are present inside the nucleus. Neutron and proton. They have their antiparticles, anti-neutron, anti-proton. So, we can say that the nucleon family has two members only, neutron and proton. Hyperons. Now, hyperons have the different families there. Lambda has only one particle, right? Then sigma family, three member, xi, and then omega. Sigma positive, sigma naught, sigma negative, xi naught, and omega negative. One member, three member, two member, and one member. It is very important, and here we have a nucleon, two members only. Very, very important. We have to remember the number of members present in a particular family, because in the coming lecture we are taking this into account, whether we will do the calculations or different simplifications. We know what are the members of the family. Similarly, in mesons, one member there, two members, and then three members. Here, how much members? Total six members, six leptons. So this is the classification of elementary particle according to this rule, right? Now there are different ways of classification, but this is one of them. The important thing that I want to tell you here, that these leptons, I have taken them here. These leptons are also fundamental particles, right? Fundamental means they cannot be break down further. As I was giving you an example of this, GABA, right? That it can be cut down into small pieces, but we will ultimately arrive at a level that we can't go further that. So leptons, six leptons are fundamental particles also, right? But these mesons and virions, they are not fundamental. They are further made up of particles which we call as quarks, right? We will also discuss about the quarks in details in this chapter. But here I want to tell you that these mesons and virions, they are made up of particles which are known as quarks, right? All these particles, all these families, and again quarks have six types: up, down, charm, strange, top, bottom. Six quarks are there. So we have now, and these quarks are the fundamental particles. Remember, these quarks are fundamental particles. They cannot be break down further. So it means we have six leptons and six quarks as a fundamental particle. So at present, what is the knowledge we have today? 12 fundamental particles are there. 6 leptons plus 6 quarks, right? So these are the 6 leptons and these are 6 quarks. These quarks are the building block of all these particles, that are mesons and virions. And collectively we call these particles as hadrons. Mesons and baryons are collectively known as hadrons. Remember it, hadrons, right? So in some topics you can see the word hadrons. Hadrons means mesons and virions. and hadrons are made up of quarks, right? So this is the one way of classifying elementary particle. You have to remember this tree of elementary particles and their families. Now I am showing you one more way of classify the elementary particles. Now elementary particle can be classified according to their spin property, quantum spin property. So we know very well in the nature two types of particles are there, bosons and fermions. You know very well what is a boson and what is a fermions. It is written here, elementary bosons and elementary fermions and elementary bosons. Half integral spin of a Fermi-Dirac statistics, integral spin of a Bose-Einstein statistics. Now, elementary particles, they are quarks, right, and antiquarks, leptons and anti-leptons, right. So as I told you that these elementary fermions, they have we have six total quarks. You can see here three generations, up, down, charm, strange, top, bottom, and electron, neutrino, mu, neutrino, tau, neutrino. So six leptons and six quarks. These are the fundamental particles, or we call them as also elementary particles, but they are also fundamental, right? Similarly, we have elementary bosons. Now, elementary bosons are further divided into two groups, Gauss bosons and scalar bosons. Gauss bosons are those bosons which have spin 1 or 2 and they are the force carriers. I mean, they are involved in the working of four fundamental forces of the nature, right? So these are called Gauss bosons. They are photons, electromagnetic interaction में involve होते हैं. W and Z bosons weak interaction में involve होते हैं, right? Gluons वो involve होते हैं strong interaction में. Gravitons involve होते हैं gravity में. और Higgs bosons, it is known as scalar bosons, right? It has different properties, so I am not going into all that, but you have to remember that this is also the way of classifying these elementary particles, and we can say these are fundamental particles also. This one and these one, right? Now you can further see down the classification of one more type, elementary particle. Here matter and here force carrier. Same thing. Matter is made up of 6 quarks, right, and 6 leptons. As I told you, and quarks further make hadrons. I already explained it, which are made up, which further makes mesons and baryons. Baryons contains nucleons, and nucleons made atoms. Atoms made molecules, right, and lepton along with these nuclei, right, because when a nucleus is there, neutron and protons are there, and around the nucleus we will have either electron revolving in different cells, or it is emitting or being absorbed. So for the formation of the entire matter in the universe, we are starting from molecule to atom, atom to nucleus, and lepton, nucleus to baryons, baryons to this, and ultimately you can see that the entire matter is made up of these two parts, quarks and leptons. Similarly, you can see here gluons involve in strong interaction, WZ bosons involving in weak interaction, photon involving in strong interaction, graviton involving in gravity, right? So if we combine a weak force with the electromagnetism, then we will have a electroweak theory, right? And electromagnetism is when it is joined together, electrostatic and magnetostatics, we have a electromagnetism, and the quantum theory for it, quantum electrodynamics, right? This is electroweak. Electroweak means we are combining this one and this one together. We will have an electroweak theory, and we have already developed it. When I combine this electroweak theory with this quantum chromodynamics is basically the quantum theory of the working of strong force. So we have a grand unified theory that combine this one and this one, right? And this is quantum gravity, the theory that explains the gravity at the quantum level. So if we join all these together, we will have a theory of everything, right? That is the task of the modern force to reach at the theory of everything. But the problem is in this one. We are not having any systematic quantum gravity theory, right? So this is one more way of classifying the elementary particle. It is also important for you, but the main thing is this tree. You have to remember it. Now in the coming lecture, I will discuss the properties of these elementary particles, right? So thank you very much.